Okay, this is just a test. I'm going to start with the DEB mock exams. I'm going to do the 2021s, this year's ones, paper 1, question 1. Question 1 says, if p is a root of this cubic equation, 3x cubed and all this stuff, find the value of p. So, what we know is that we have this cubic equation. If p is a root, then it solves the equation equal to 0. So you just would sub in p for x. It's just like any quadratic equation. If you knew a solution to the quadratic equation as a root, well then you know it solves it equal to 0. So it might seem strange, but we just literally sub in these x's. We change them out for p's. So I'll do it in pen here to see. So we get 3p cubed plus p plus 3. And now we have a p squared plus, and we have 7 minus p minus 4p squared times another p, and then minus 4 equal to 0. So I've just changed all the x's for p's, and I'll multiply out these brackets. 3p cubed plus now p squared by p, another p cubed, p squared by 3, 3p squared, 7 times the p, and minus 4p cubed minus 4 equal to 0. Now, just like any other equation, we'll try and group some like terms together. So we see we have a 3p cubed and a p cubed. That gives, let's say, 4p cubed. So literally, we can actually cancel this 4p cubed because it's a minus. With this, I have 4p cubed here. So 3p cubed, 3p cubed is 4p cubed minus that. So these will all go. Now I have a 3p squared minus p squared. That gives me a 2p squared. So I'll cross these off as I'm done. 7p on its own. And minus 4 equals to 0. And now we have a standard quadratic equation. And remember, for all quadratic equations like this, we should be able to get two solutions for it. Now you can simply use the minus b formula if you're unsure here, especially when you have a leading coefficient with the x squared. But if you're good at your quadratic equations, you may see that actually you can solve this without actually using minus b. But feel free to use the minus b if that's easier for you. So I'll open two brackets, a 2p and a p, and then I said equal to 0. So we have 2p, I think it's minus 1 and then plus 4. So we're looking for solutions for p, so we'll set each of these individual brackets to 0. So that's 2p minus 1 is either equal to 0 or p plus 4 is equal to 0. That gives us 2p is equal to 1 and p is equal to a half, or p is equal to minus 4. Now we can't actually take this solution because the question says that p is an element of the integers, and the integers are whole numbers only. They can be negative or positive. So we actually can't take a half then. So this is no longer our answer, and this one here is. So first question done, p is equal to minus 4. Now on to part 2, question 1. So they want us to solve this equation that they gave us in the first part, writing irrational solutions as a plus or minus root b over c. This part's important. I always say never go to decimal. If you ever have to go to decimal, they'll tell you pretty clear in the question to give your answer correct to 1 decimal or maybe 2 decimal places, but especially in higher level maths, just make sure you write your answer as this. So in the first part we figured out that p was equal to minus 4. So we'll just replace all the p's here by minus 4 and see what we get. That's 3x cubed plus minus 4 plus 3x squared 7 minus. Now we'll use brackets for the minus 4 because the double negative, just to be super careful. Minus 4 by minus 4 squared x minus a 4 equals to 0. So that's going to give us 3x cubed minus x squared, and I think all this stuff here gives us a minus 53x, and that gives us a minus 4 equals to 0. Okay, so we have this cubic equation. Now they did tell us in part 1 that p equal to minus 4, that p was a solution. So we're going to use something now called the factor theorem. So just to remind you, the factor theorem says to have a solution, you can get a factor. So since x equals to minus 4 is a solution, and that implies then that x plus 4 is a factor. So we can simply divide this factor into this cubic equation. That'll give us a quadratic equation, which then we can solve pretty easily for the other two factors. So, a small bit of long division. So, 3x cubed minus x squared minus our 53x minus our 4. So, we'll do this nice and slow. So, the way I think of it is x multiplied by what gives you 3x cubed. So x multiplied by 3x squared give us that 3x cubed. And similarly, we have to multiply this by the 4 as well. That gives us a plus 12x squared. Now what I like to do here is draw a little different colour symbol because we're changing the signs. Effectively what we're adding them instead of subtracting. So it makes it easier not to mess up the signs. So 3x cubed and now a minus 3x cubed cancel each other out. Minus x squared minus 12x squared gives us a minus 13x squared. Bring this guy down. And now we do the same again with the leading number here. So x times what gives us minus 13x squared. That's minus 13x. So that's going to be minus 13x squared. And similarly this times the 4. That's going to give us a minus 52x. We'll draw our line. We'll change our signs. These cancel. Minus 53 now plus 52x. That gives us a minus 1x. So bring this guy down here. And now, x times what gives us minus x? That's a minus 1. Okay, so minus 1 then times x, that's simply minus x, and minus 1 times 4, minus 4. And that's what we're looking for, to have, since it is a factor, we know there should be no remainder, that cancels. So we're left with this guy here, this quadratic. And of course that's a whole new problem to solve. So if we write that here, let's say 3x squared minus 13x minus 1. So there's no easy way to do this. We literally have to use the minus b formula here. Now I think a good process to stick to here, especially in practice and maybe you mightn't have time during the exam, would be always to write the formula first, which is our minus b formula given to you in your logbook over 2a. And then always a good idea to write over here what a is equal to, what b is equal to, and what c is equal to. So a here is the coefficient with x squared, which is 3. B is the coefficient with x, which is minus 13. And c is the constant on its own, which is minus 1. So putting all these, replacing these letters by these numbers, gives us minus 13 plus or minus the square root of b again, which is minus 13 squared minus 4 times 3 by minus 1 all over 2 times a, which is 2 times 3. So minus 13 gives us a plus 13, plus or minus, I'm sure you'll use a calculator to solve all this, but you should get a 181 underneath that square root all over 6. So this would definitely go to decimal, so remember we don't want to go to decimal because they told us to give our answer looking like this. So we have two answers here. We have 13 plus the square root of 181 over 6, and we have 13 minus the square root of 181 over 6. And of course we have the solution from the very first part, which was our minus 4. So that's part 2 done. Our 3 solutions. So we're on to the last part of question 1, part B, and it gives us this picture of a function. Now obviously I've freehand drawn it here, so it's not going to don't mind the scale, but I have the important things marked in here. It says the function is some sort of cubic function. It looks like ax cubed bx squared plus cx plus a d, where a, b and c and d are numbers we have to find. Now what's important here is we can see the roots clearly. So the roots, when I talk about roots, obviously I mean the x-intercept, but we can also see the y-intercept here, and that'll be more important later on. Just as a quick reminder, a quadratic equation always has 2 roots, right? And then a cubic equation has 3 roots, or 3 solutions, or if you like, equal to 0. Now again, we're going to use what we spoke about in part 2, which is the factor theorem here. Right? So since we can see the 2 roots, we know that solutions are x equals to -2 twice and x equal to 3. We can actually make factors from those the same way we did in the first part. Now x equal to -2 is a repeated root. It sits on the x-axis. Sometimes people call it a saddle point. That means that we can write that twice, right? So we have x, right, plus 2, because remember we changed the sign to bring it back over to be a factor. Again by another x plus 2, multiplied then by an x minus 3. Remember, we're bringing the number back over to make it a factor. But we still have to figure out what constant. Like it could be a 2x cubed, 3x cubed. It could be a number of different numbers. So we have to figure that out. So we will put in a k for that. Okay. So what I'll do now is I'll actually just multiply out these brackets here. I'll leave the k on the outside. So x plus 2 times x plus 2 is essentially x plus 2 squared. So if we think that's going to be x squared plus a 4x plus a 4, that's now going to be multiplied by x minus 3. We still have our k outside. Let's just do these brackets. So x squared times x, x cubed. X squared times minus 3, minus 3x squared. And then we're going to the 4x times x, 4x squared. 4x times minus 3, minus 12x. Now on to the 4 times x, 4x, 4 times minus 3, minus 12. Now we'll still keep our k out there, and we'll group these terms together that are like. So only the 1 cubic, so x cubed. So minus 3x squared plus 4x squared, that gives us a plus x squared on its own. So I like to cross them off when we're done. Minus 12x plus 4x, that's a minus 8x. And then a minus 12. So we're down here with like so. So we know f of x looks something like this, but we're not sure what this k is. But remember from functions, we know a couple of definite points on this graph. What's nice here is we actually know this point here where it crosses the y-axis. This point here on the y-axis would have an x-coordinate of 0, but a y-coordinate of 24. Essentially that means if we put 0 in for x, we should get a y value back of 24. Remember, that's how functions work. So let's see what happens if we do that. So f of 0 gives us k times, we're replacing now all the x's by 0. Now once we do all this, the function says we should get an answer of 24. So essentially we can set that equal to 24. This becomes pretty simplified in the middle because these zeros now are all gone. And all we're left is k times minus 12, because 0 cubed is 0, 0 squared, a times 0, all gone. So we get minus 12 times k equals to 24. And of course that says us then that k must be equal to 24 divided by that stuff, which is minus 2. So now, we actually know that we can replace this k here by minus 2. So we know the actual function f of x looks something like this. Minus 2 times x cubed plus x squared minus 8x minus 12. Multiplying that 2 gives us minus 2 x cubed minus 2 x squared plus 16x, and minus by minus again, plus 24. So when we compare our answer to what it said it should look like, we can see that the coefficient of x cubed is minus 2, so a is equal to minus 2. The coefficient of x squared being b is also a minus 2. The coefficient of x being c is a 16. And the number on its own d is a 24. That's it. Question number 1 done.